All right, this is your lesson on 7.3 decomposition of rational expressions. You will use the system of linear equations to write partial fractions decomposition of rational expressions. In algebra, you learn how to add two rational expressions. Rational means fractions. Add two fractions with x's in them, rational expressions. By getting a common denominator. So we would have to change this first fraction to have a common denominator of the product of these two denominators. So it would be x minus 3 times x plus 2. So in order to get that, we have to multiply the 2 by x plus 2 to get this common denominator. Also on the other side, here in the second fraction, we'd multiply that one by x minus 3 on the numerator and denominator. Now we have a common denominator. We have this set up here. Distributing the 2 and distributing the negative 1, I get this down here. Combining my like terms, and I get x plus 7 over x minus 3 times x plus 2. Now that was in Algebra 1. Now we're going to learn to take this apart. What if I gave you this and asked you to decompose, break it up into two fractions like this, going backwards? Okay, let's start with what we just got. You notice that we have to get a product and a denominator to know what the decomposition is. So we have to factor the denominator into factors. When we factor it, we get two factors. That means we're going to get two fractions that we're going to add together. So here, one factor times another factor, we're going to get this. If we had three factors down here, we would have three fractions over here. We don't know what the numerators are. Don't make the biggest mistake here in putting the x on one and the 7 on the other, okay? We don't know what they are before we added them together, so we can call them a and b. Now, if we're to add these to get this, that means we have to get a common denominator. So when we get a common denominator, we'll have to multiply the numerator and denominator by the other denominator. And also over here on the second fraction, same thing. So now that we have a common denominator, we don't care about the denominators anymore. We're just going to look at the numerators. So now on this left side, we have x plus 7 is equal to the a times x plus 2 and the b times x minus 3. Like we did before, we distributed this part here and this part here, combining my like terms, and I get this. That means that the a plus b has to, times x has to equal the 1 times x. Right? That's the only way we can get this x here. So we can rewrite that as 1x is equal to a plus bx. While getting rid of the x's on both sides, dividing through by x, we can get a is equal to, 1 is equal to a plus b. So this a plus b is equal to the 1 as the coefficient on the x. Now we're going to get another equation. We're going to take the 2a minus 3b, and we'll make that equal to the other part, the 7. Okay, because these two don't have x's, and the 7 doesn't have an x, but these two had x's, and that one had an x. So we make that equal so that we know that 7 has to equal 2a minus 3b. Now we have these two equations, and I'm going to use elimination to solve for them. Okay, so it looks like if I have a negative 3 here, I want a 3 here, so I'm going to multiply by 3 to get 3 is equal to 3a plus 3b. Adding these two equations by elimination, okay, adding straight up and down, I get 10 is equal to 5a plus 0. Dividing by 5, I get a is equal to 2. Now I want b, and the easiest place to get b is to find the easiest equation over here. We can use any one we want, but I'm not going to play with any of those. I'm going to look at this one down here. And I can put the 2 in for a, and b has to equal negative 1. Okay, so now I know that the a is equal to 2 and the b is equal to negative 1. I put those back on top. And notice I just, instead of adding a plus a negative 1, I just put the negative in front of my fraction here. So it's 2 which is a over x minus 3, minus 1 over x plus 2. All right, let's do another one. Okay, decompose this fraction. Okay, if you took careful notes, you should be able to pause it at this point and try and figure it out yourself. If not, you can watch a little bit of a time, pause it as soon as you get caught up, and then finish the problem and continue. Okay. First, I'm going to factor the denominator because I need to know what the factors are, or what the individual fractions were, the denominators were. We don't do anything to the numerator. So now we have the two factors, the x plus 2 and the x plus 4. We don't know what the numerators are, so I just put a and b. Get a common denominator, which we will multiply the a by the x plus 4, multiply the b by the x plus 2. I get this is equal to x plus 8. Collecting all my terms, now I know that 1x is equal to ax plus bx. And I also know that a is equal 8 is equal to 4 plus 2 because those didn't have any x. These two didn't have any x's. Using elimination, it looks like I could multiply by negative 2 and get negative 2 is equal to negative 2a minus 2b. Adding these two together by elimination, I get 6 is equal to 2a. And dividing by 2, I get a is equal to 3. Putting the 3 back in here, 3 plus what number gives me 1? It looks like a negative 2. And putting all this back on top here, I get 3 over x plus 2 minus 2 over x plus 4. Now, at any point where you finish, you go, oh, I don't know if that's correct. You can always add these two with a common denominator and see if you can get back to the original problem. If you can, then you did it right. If you didn't, then you did it wrong. And try it again. There's lots of places for you to make a little math error. So just look for the little math errors. And if you can't get to the answer, always check back to see if you copied down the original problem correctly. That's one of the mistakes that I find people are making. Here's another one. This one I've already did the denominator or factored the denominator for you. So go ahead and try it. Pause it. See if you can come up with the answer. All right, I hope you gave it a good try. So I have these two fractions, one for each of the factors of the denominator. I don't know what the numerators are. Do a little cross multiplying here, a times 2x minus 1 and b times x plus 2, and I get this. Collecting all my x terms, I get 5 is equal to 2a plus b. I get negative 10 is equal to negative a plus 2b. Doing an elimination, multiplying by negative 2 to cancel my b's. Okay, now I have a positive 2 and a negative 2, then the b's go away. Adding these two together, I get negative 20 is equal to negative 5a. Divide by negative 5, a is equal to 4. Putting that back in this problem or this equation over here. 2 times 4 is 8. Subtract 8 from both sides. I get b is equal to negative 3. Putting these back up here, I get 4 over x plus 2 and negative 3 over 2x minus 1. So at some point you're going to go, does it matter which way I put these? No. If you put the 2x minus 1 first, then your a's and b's will switch, and then your answer will still look like this. You might have the negative 3 over 2x minus 1 first, plus 4 over x plus 2, but you should realize that those two are the same answers. All right, let's try one that's a little trickier. Make sure you know how to factor the denominator. Pause it here and see if you can struggle through that. And if you can't, come and look. All right. Whenever you factor anything, always take out the greatest common factor first. That's your main objective. So my greatest common factor is an x. Take out an x, then you're left with x squared plus 2x plus 1. You factor that, and it becomes x plus 1, x plus 1. So you factor out the greatest common factor first. Now, here is the tricky part when you have duplicate factors. If you have two factors, don't make this into an x as one, and then x plus 1 as another one, and then x plus 1 as another one, because notice that these two should have the same numerator because it has the same denominator. We don't want that. We need 3 unique or 3 different denominators. So to get 3 different denominators, I have to do some kind of combination of these to make 3. So I'm going to use x and x plus 1, and then the third one can't just be x plus 1 again because it will look just like this one. So I have to either use a product of these two or a product of these two. So this could have been x times x plus 1, or I'm just going to use x plus 1 squared. Notice that now that when we try and get a common denominator, this whole thing is my common denominator. That means I only have an x, so I'll need an x squared, or both of these terms, to make this work. On the b, I only have one of these x plus 1, so I need an x times x plus 1 to make that work. On the c, I already have both of these, and all I need is an x. So what that'll look like is that a will have to be multiplied by both of these because all I have is an x. And under the b, I have both of these, so I need one more of these. So that, I had one of these and I need both of these. So the b has to be multiplied by both of these. And the c, I'm pretty good. I have both of these and all I need is an x. So now I have this set up here. Doing some algebra, you just FOIL that out, distribute, FOILing that out, distributing the x, now distributing the a and the b. I should have all of this mess right here. All right, a lot of terms. Now I'll just start collecting them. Collect all the x squared terms. Then that means 5 has to equal a plus b. Those are the ones with the x squareds. Then I'm going to collect all the x terms, which is the 20 and the 2a and the bx and the c. So that's going to be one equation. And in this particular problem, you can get a freebie. Not all of them will do that, but you can get a freebie here because you can get a 6 is equal to a. That's the only one without the x's. So you have one already done for you. All right, now I'm going to take the 6, put it back over here, and I can get a b. Subtract 6 from both sides. B is -1. Putting both a and b in here, and I should be able to get c. 2 times 6 plus a -1 plus c. And I get 12 plus a -1, or 11. Subtract the 11 from both sides and get 9. Putting all the a and the b and the c back up here, I finish off with 6 over x minus 1 over x plus 1 plus 9 over x plus 1 squared. Okay. One last one you're going to do. Try and do this all by yourself if you can. If you can't, then you're going to have to take a little peek. As soon as you get where I'm going, so maybe you should pause it again and try and finish the rest of the problem. Okay. All right, here I go. I factor it, and I get x times x minus 1 times x minus 1. So my 3 unique denominators, or 3 unique factors, have to be all different. So I'm going to put in x, x minus 1, and x minus 1 squared. Okay, and then multiplying by what I don't have, I get all of this. Foiling and distributing, I get all of this. Collecting all my x squareds, I get 3 is equal to a plus b. Collecting all my x terms, I get a -1 is equal to -2a minus b plus c. And then in this case, I do get a freebie, not always, but this was an easy one. So I get 5 is equal to a. Doing a back substitution all the way through, I get b is equal to -2. C is equal to 7. Putting this all back together, my final answer. Okay, hope that wasn't too bad. You're going to be doing the Google form, and the problems that you will have to do are, since I can't really put these equations or these expressions in the Google form, I have it on the video. So you will need to do these Google form questions. Number 1, what is the common denominator for these rational expressions? Which one of these has the common denominator for these three fractions when you're trying to add them? Number 2, which expression is the general form? Don't solve it, just write it out, okay? When you try and decompose this, which one of these four choices would you have to write in order to get that apart? Number 3, what about this one? Which three choices would be best to take this thing apart? And number 4, you're going to fully decompose this problem as one of these. Number 5, you're going to decompose this into one of these. And number 6, a little bit of a challenge, but if you get the lesson, then this should be easy. If not, go watch the video again, look over your notes. All right, thank you very much.